Okay, class. In this lesson, I'm going to go over probably the most important aspect of all mathematics, especially in Integrated Math 1, and that is solving linear equations. Now, it's really important to pay attention very closely because this is going to establish the foundation that you're going to need to move forward to Integrated Math 2 as well as Integrated Math 3. So the best way to explain how this works is to go through a few examples. But before we do that, I want to establish a couple rules. So rule number one is to isolate the variable. In other words, you want to get the variable by itself on one side of the equation and move everything else to the other side of the equation. And the second rule is whatever you do to one side of the equation, you must do the same exact thing to the other side of the equation. And the reason for that is you want to make sure that the equation is always balanced. Otherwise, if you don't do that, it will not be equal. So let's start with one example. So in this example 1, we have x plus 3 is equal to 5. If you take a look at this, you could probably guess fairly easy what that x needs to be when added to 3 is equal to 5. But I'm going to walk you through the mechanics, and it's important to understand the mechanics so you understand how to do more complicated problems. So if we were to follow the first rule, which is isolate the variable, okay, we want x by itself. We need to figure out what to do with this positive 3. Okay? Now, if we want to get rid of this positive 3, the logical thing to do is to subtract 3. So if we were to subtract 3 from this side of the equation, then we must do the same thing to this side of the equation. Okay? We're going to subtract 3 on the left side of the equation. We're going to subtract 3 on the right side of the equation. By doing this, we see that these cancel out. Okay, 3 minus 3 is 0. So now what we've done is isolated x by itself because there's nothing else on the left side of the equation. Okay, here's the equation or the equal sign. There's nothing left on the left side. And then what we're left with is x is equal to 5 minus 3. And now that we solve for 5 minus 3, we find that x is equal to 2. Okay? Hopefully that made sense. So now I'm going to go through another example, a similar one, but with a slight variation. So here's example 2, and we're going to go with a minus 2 is equal to 10. Okay? Now, we want to isolate a so that it's by itself on this side of the equation. Okay? We have a negative 2 here. So in order to get rid of this negative 2, we have to do something to that negative 2. And what we're going to do is we're going to add a positive 2. And whatever we do to one side of the equation, remember we have to do to the other. Okay? So again, we've followed rule number 1. We're going to isolate the variable. So that's our goal. Isolate the variable. Then we're going to do number 2, which is whatever you do to one side of the equation. In this case, we're adding 2. We have to do the same to the other side. Okay? So now these cancel out. Okay? And now we're left with a is equal to 10 plus 2. And solving 10 plus 2, we find that a is equal to 12. Okay, so let's just review. And let's just take a look at example 1 and 2. In example 1, okay, in order to isolate x, we had to subtract a number. In this case, we were subtracting 3 on both sides. Okay, with example 2, okay, we had to, in order to isolate a, we actually had to add 2. And the reason that we're adding 2 is because we have a negative 2 here. So we have to do something or the opposite, right, to eliminate this so that it becomes 0. Okay, so now let's look at example number 3. Okay, so with our third example, we're going to have 5t is equal to 45. Okay, now this one's a little bit different, but we still need to do what number 1 says, which is isolate the variable. And how do we isolate the variable? So let's think about the end game. If we get this to be t equals some answer, okay, what do we know about the coefficient in front of t? Okay, now what do I mean by coefficient? What is the number in front of t that is implied but not written out? Okay, the answer is it is actually 1t. Okay, in algebra or in mathematics, we don't use the coefficient 1 because it's unnecessary or redundant. So what's implied is that the coefficient in front of any variable, if there's no other coefficient, is the number 1. Okay, so then let's go back to this example. We have 5t is equal to 45. What do we need to do to get t alone? So in other words, how do we make this 1t? Well, if you remember from earlier math, to make this 1t, we actually have to multiply this side of the equation by 1/5, or its reciprocal. Okay, this is called the reciprocal. Okay, it's the reciprocal. It's 1 over the number that you're trying to get rid of. 1 over this number that we're trying to get rid of. Okay, now remember rule number 2. Whatever we do to one side of the equation, we have to do the same thing to the other side. So that means this is going to be multiplied by 1/5. Okay, and when we do that, these cancel out and this just becomes t. Okay, just like this. Remember, the coefficient in front of t is implied to be 1, and that is what we have achieved here. Okay, this is equal to 1. So therefore we have 1t over here. But we don't really need to write that. Okay, so it's implied. And then continuing on, t is now equal to 45 divided by 5. Okay, all I did was I multiplied 45 by 1/5. Now we can solve for t. We find that t is equal to 9. Okay, let's look at another example, example number 4. And we're going to have k over 3 is equal to 9. Okay, now don't let this scare you. It looks a little bit funny, but all we need to do is continue to follow the rules. Okay, rule number 1 is we want to isolate the variable. So the question here is, how do we get k by itself? If we see k over 3 slightly differently, what we find is that this is really 1/3 times k is equal to 9. Okay, so all I did was I separated this term into two different terms so that it becomes 1/3 times k, because 1/3 times k is k over 3. Okay, now that we see that this is the coefficient, right, the number before the variable, okay, what do we need to do to this number so that the coefficient in front of k is equal to 1? Well, the answer is we multiply both sides by 3. Okay, and when we do that, we get these canceled out because 3 times 1/3 is 1. And now we've isolated k. And now we could solve for 9 times 3, which is 27. Okay, I hope this made sense. It's really important for you to follow these 4 examples and make sure it's etched in your brain so that you really, really understand this. If it didn't make sense or if you're not quite sure, please redo or re-look at this video and go over this again as many times as you need to until you fully understand it. Here's the reason why. Again, as I said at the very beginning, this becomes the basis or the foundation for algebra. If you can get this, then no matter how complicated equations become, you will be able to solve every equation. Okay, thanks and good luck.